average time to mass. So you need to know that equation. You need to know how to do the calculation. And actually, one of the questions in the quiz that you're supposed to turn in next Monday is about this particular type of calculation. Okay. So look into, and when you read the textbook there, make sure you pay attention to the example there. Now, the best thing about this particular textbook there is that the author tried to give you examples and show you step-by-step solutions. And after that, we have another practice problem. And practice problem is very much similar to the example that you just saw in the textbook there. So if you understand how the problem was solved in the example, you should be able to do those practice problems. And the answer of the practice problem is also given at the end of each chapter. Okay, so you need to make sure that you do those practice problems in the textbook as well. Remember, you are in Chem is try class, so you got to try it. Okay, so make sure after class there, make sure you do the calculations there. We gave you this particular equation. Now this equation is in your textbook. And this is something that you need to remember. Now remember all of these quantities here, and we will give you every single one of them but one. Okay. So there's always going to be one and m. We can ask you to calculate this quantity on the left side of the equation, or we can give you this, ask you to calculate one of those quantities, one of these quantities here on the right side of the equation. So you know the equation there. You have one equation, one n now. Basic algebra, you should be able to solve that problem. Okay, so this is an example on how to determine the weighted average time to mass there. Okay, and then there are more examples after class. Make sure you take the time to go through that. And it may be confusing sometimes based on my past experience there. People are always confused about what number to use. Sometimes when they plug in the number, percentage number, they forgot to convert it into decimal. So that's something that you always need to pay attention to. And then look at the example there. Okay, and do the practice and do your homework there. And we have several questions in the homework. And also, you should start working on the quiz number 1. And some of the questions in quiz number 1 related to the course policy outlined in the syllabus. And some of them are related to dimensional analysis and SIGFIG. And then one of the questions asks you to calculate the weighted average time to mass. So that's something that you should start working on. Okay, and so when we were talking about the structure of an atom, we say atoms are made up of protons and electrons and neutrons, and there are equal number of protons and neutrons in an atom. The protons and electrons in an atom there. So there is no net charge. However, when two different types of atoms meet with one another, something happens. That's a chemical reaction happens there. And a chemical reaction, in essence, the result of a chemical reaction is the transfer of electrons from one species to another. So one particular atom, you begin with equal number of proton and electron there. If that particular atom meets another atom there, well, they will exchange their electrons. And that's how the chemical reaction happens there. So when you start to give out electrons or taking in electrons, you would end up with different number of protons and electrons. And that's where the term ion comes in. So ion is either an atom or a group of atoms that has an electrical charge. Electrical charge can be either positive or negative. Okay, so in this case, the positive ion, when we use the term cation. Now if you type in C-A-T-I-O-N on a computer, if you're using Word as your word processing document there, and then we'll have a red line underlined. So you need to send Bill Gates an email telling him cation is actually a word. Do not mark it as a misspelled word. Okay. And now if you have a negative ion there, we use the term anion. Somehow anion, they don't underline that word there. So anion is probably accepted by Bill Gates, and cation is not. Okay. So there are terms associated with positively charged ion, negatively charged ion, and terminology is important. So make sure you pay attention to this. So how is an ion formed? What happens? Well, we use the sodium as an example there. If you have sodium and you look at the sodium there, the sodium is number 11. Okay. Now, how do you know that? Well, I've been using periodic table pretty much throughout my life there. By the time you finish this course, you will memorize most of these elements in the periodic sodium number 11. What does number 11 mean? It means you have 11 positive charges, you have 11 negative charges. Sodium happens to be what we call a metal. How do you define metal? Non-metal. We'll talk about that a little bit later in this chapter there. So using sodium as an example there, how the formation of a cation, possibly charged ion, metal tend to lose electrons in chemical reaction. You ask why? Well, we'll talk about that in the periodic law, starting in chapter 7, chapter 8 later on. Okay, so now that you know that metals tend to lose electrons in chemical reaction, sodium number 11. So we have 11 protons, we have 11 electrons to begin with. In the process of chemical reaction, sodium will give out 1 electron. Now the result of that is you still have 11 positive charges, but after losing that 1 electron, you only have 10 negative charges. Therefore, you form what we call a cation, sodium cation. We put a positive sign on the upper right corner, representing that positive charge. There is only 1 positive charge here. Well, you don't need to put the number 1 in here. But if a particular atom loses more than 1 electron, say if you lose 2 electrons there, then you put the number 2 in there, 2 positive charges. Okay, so this is the formation of the ion there, and the formation of the anion there. Chlorine number 35, chlorine number 17. Okay, if you look at the periodic table there, chlorine is number 17. 17 means that you have 17 positive charges, 17 negative charges. Okay, so chlorine is a non-metal. That's a new term that we haven't talked about yet. We will get into those terminologies a little bit later in this chapter here. So non-metal, when the chemical reaction happens there, non-metal tends to take in electrons. Okay. So in this case, you start with 17 protons, 17 electrons there, and in the course of the chemical reaction there, and chlorine would gain 1 electron. As a result, you would have 17 positive charges, but now you have 18 negative charges. This is the formation of the anion there. We put a negative sign on the upper right corner of the atomic symbol. If you have more than 1 negative charges there, you put the number in, 2, 3, 4, whatever. Okay, so this number, when it's 1, you don't have to write the number 1 out, but when it's more than 1, you've got to put the numbers in. So this is the formation of the cation versus the formation of the anion. One is given out electron, the other is getting electron, gaining electron. Okay, so that's how the ion is formed. Now, metal versus non-metal. That's the term that we're using here. Okay. Metal tend to lose electrons in chemical reaction, and non-metal tend to gain electrons. How do we classify metal and non-metal? When we talk about the organization of the periodic table, we will get to that point. Okay, so for now, we just need you to remember, whenever you have a metal elements there, when they react with non-metal there, metal will give out electrons, non-metal will pick up electrons. Okay, so in this case, you always want to ask, why do metals give out electrons there? And there's always an underlying reason. And the theory, the modern chemistry theory, actually figured all those things out. We will explain why metal loses electron, why non-metal gains electron, and when we look at the energy aspect of the chemical process, the chemical physical changes there. So metal have what we call a small ionization energy. Now, ionization energy is the term that we use to describe the amount of energy used